Welcome to Year 1, Chapter 12.5, where we continue looking at differentiating, but this time we look at some hard functions. Well, last time we looked at quadratics, too easy, isn't it? So this time we look at different ones, like roots, like fractions, like brackets, and numbers in denominator. Okay, so one by one, I'll show an example of each, how to differentiate each of them. Um, First one is roots. So for the roots, it's probably easier if we know to differentiate, we need a power. So we can change the cube root into a power of third. So you need to know your algebra quite basic, quite nicely, so you can differentiate. So x to the power of cube root means x to the power of third. Now, once we've got x to the power of third, we can differentiate easily. So multiply by the power, and then power multiplied by 1. 1/3 minus 1 is negative 2/3. And that's it. Okay. You can rewrite them a bit neater as in cube root and maybe square something, but it's not too important. In algebra terms, it's good to leave it as a negative power as it is. Okay. Fractions. Now, when you see multiple numerators in the fraction, okay, split them up like pickles in a burger. We don't like pickles in a burger, or I don't. So that's why I split them up. Okay. The first thing I do is take it away. So that's what I do in here. I split them up. So split up the numerator. So plus 3 over root x. Remember, denominator stay the same throughout the whole both fractions because you're just splitting up the numerator. You can't split up the denominator. Okay, so just for example, okay, just to show you, okay, two examples. Let's say 3 plus 1 over 7. Okay, you can split up as 3 over 7 plus 1 over 7. But let's say if you have 3 over 7 plus 1, you can't do 3 over 7 plus 1 over 7. Plus 3 over 1. It doesn't work that way. Okay, so just to make you aware. Okay, so we can now simplify the algebra before differentiate. Now take note the left hand side where I've not changed to dy by dx because I've not differentiated. I'm just rewriting it into a way where I could differentiate. Okay, just like removing the pickles in the burger before I can eat them nicely. So x to the power of 2 over x to the power of a half plus 3 over x to the power of a half. Then what I can do in here is I can simplify the first term by subtracting the power. So 2 minus a half is 3 over 2. X to the power of a half denominator is same as x to the power of minus a half. Okay, so now I'm good to differentiate because both x is in a power form. Multiply by the power, power minus 1. 3 over 2 minus 1 is a half. Multiply minus a half into 3 is negative 3 over 2 minus 1. Okay, now be careful when you do minus a half minus 1. It's not a half, it's negative 3 over 2. So whenever in doubt, use a calculator, even as simple as minus a half minus 1. Okay, because these are the little bits that people can make a mistake. In A level, you can use a calculator. Trust your calculator. Just use it. All right. So, next one, brackets. Simple. Just expand it. Okay. Just expand it. Now, if you're in year 13, you might have learned a different way to differentiate this, but I would say technically it's harder because it's not quite necessary in here. So, if you're 12, that's fine. Just multiply, expand the bracket. So x cubed minus 3x squared. And then do differentiation. Okay. 3x squared minus multiply 6x. Simple. Right? Next one. What about numbers in denominator? Now you see a 13 here. Now the reason I want to bring this example is because a lot of students, okay, will write as y equal, okay, 3 times 1 over x, which is wrong. Okay, what you should be writing is y equals a third times 1 over x. So the 3 in denominator means a third. Now be careful with this one. Okay, y equals, so now I can write a third x to the power of minus 1. Note the coefficient is a third, not 3. Once I differentiate, okay, I can multiply by the power minus a third. Power goes down by 1. Right? Easy. Right? If you find it easy, good enough to try it, okay, I'll suggest you have a go at practice question 1. Pause the video, have a go. When you're ready for the answer, you can press play. And here are the answers. Okay, question A, quite simple. You change the root x in denominator to power of negative a half is negative because in denominator you multiply by the power. Power goes down by 1. Easy peasy. B, do the same, expand the bracket first, and then differentiate. C, you have to split the numerator, and write the denominator power of x into negative power, then multiply and differentiate. Simple. Now D is slightly trickier because you have more terms in there. The terms looks a bit more complicated, so you have to know how to split them up nicely. 1 over 3 root x, we can write as 1 over 3 times 1 over root x. Now for the second one, is you split coefficients, so it'll be 2/3 as a coefficient times x over root x. Now when you have x over root x, that's x to the power of 1 over x to the power of a half. 1 minus a half is a half, positive a half. So therefore, the y equals a third x to the power of negative a half minus 2/3 x to the power of a half. So once you've got this stage, then you could differentiate. Okay. Make sure you use a calculator. A third times minus a half is 1 over 6, x to the power of negative 3 over 2. And then we do 2/3 times a half is 1 over 3, x. Now, a half minus 1 is negative a half. Just be careful with that. All right. And yeah, if you're happy with this, okay, carry on. You can have a go at practice question 2 and practice question 3, which I'll go through one by one. But pause video, have a go at both questions. When you're ready for the answer, you can press play. Here's the answer, okay, for practice question 2 and practice question 3. If you got them both right, well done. That's the end of the lesson for you. Okay, otherwise, I'll go through question by question. Let's have a look at question 2. Find a gradient. We talked about last time. Gradient means differentiation. Okay, so find a gradient of y equals 3x minus 4 with x cubed at a point 2, 5.5. So let's work out dy by dx first. Okay, so let's differentiate. Actually, before differentiate, I think it'll be good to rewrite the denominator as power of negative power before differentiate. So dy by dx equals to differentiate 3x is 3. Remember, anything x to the power of 1 when differentiate is just a coefficient. All right, differentiating constant is 0. Okay, differentiate 3x is just 3. Minus, so multiply, actually plus 12x to the power of minus 4. Because minus 3 minus 1 is minus 4, not negative 2. Be careful with that. So at 2, 5.5, I can sub in the x value. So 3 plus 12 times 2 to the power of minus 4. Put that whole thing in the calculator, I get 3.75 or 15 over 4. All right, next one. Question 3. F of x equals 12 over p root x plus x. Given that f dash 2, now f dash, okay, the dash here, okay, means differentiated, and the 2 means differentiate, then sub 2, then substitute x equals 2. That's what they did. Okay, substitute x equals 2. So forget about the x equals 2. Let's work out the derivative. Let's differentiate first. Okay, so let me rewrite the question. F of x equals 12 over p root x plus x. So f dash x, let's differentiate. Actually, before we differentiate, actually, I think it'll be good to show you how we separate this fraction. So it'll be 12 over p, because p is a constant, times 1 over root x. That's how I will separate them. And then I'll rewrite as 12 over p, x to the power of negative a half, plus x. Now I can differentiate f dash x. Multiply by the power, so it'll be negative. So the half and the 12 will cancel, it'll be 6 over p, x to the power of minus 1, 3 over 2, plus 1. Differentiate x is just the coefficient, which is 1. All right, differentiate x is 1. So I'm told, okay, substitute 2 in there. So f dash 2 equals to minus 6 over p times 2 to the power of 3 over 2 plus 1. And I'm told this equals to 3. So note, what I did was I substitute x equals 2. So I substitute the 2 into the x position. Okay, then I'll put in a calculator. 2 to the power of negative 3 over 2, you should get as 1 over root 2. So, or let me put it in a calculator to see what you get. 2 to the power of negative 1.5. Or you got decimal, right? So you've got decimal. What can you do? Now, what can you do when you get decimal? So what about if you put 2 to the power of 1.5? You still get decimal. Do you get a third form? No. Sometimes I find this calculator a bit silly. You pay so much money and then you don't get a third form. Okay, so Anyway, so let's remove the plus one to right hand side. Okay, so minus 6 over p to the power of 2 over minus 3 over 2. I'll talk about how to do this. Now, why don't we multiply p to right hand side as well? So minus 6 times 2 to the power of negative 3 over 2 equals 2p. I'll show you how we get do this. 2 to the power of negative 3 over 2, we can do it manually. Well, negative means put it, negative means put it back into the denominator, 2 to the power of 3 over 2, right? Next, let's start one by one. I think probably easier if we cubed it first. If you cubed the 2, okay, 2 cubed is 8. So minus 6 over 8 to the power of a half equals 2p. Okay. Then 8 to the power of a half is the same as square root of 8. So square root of 8. Now I believe you can do this now. You can calculate 8 to the power of a half. Still not 8 to the power of 1 over 2. Yeah. Yeah. If you do 8 to the power of a half, the calculator won't give you a third form. But if you put square root of 8, then you get 2 root 2. Yeah. So put in a calculator. Equals 2 root 2. So I'll get minus 6 over 2 root 2 equals 2p. Then I'll simplify the negative 6 over 2 root 2 in the calculator and give me negative 3 over 3 root 2 over 2 equals 2p. And then the whole thing divided by 2, I get p equals to I get p equals to minus 3 root 2 over 4, which is different to my answer at the beginning. Let me just check my working out. Plus 1 equals 3. So I bring it minus 2. Yep. I don't see anything wrong in here. So I actually made a mistake in here. Let me rub it off and 4. Okay. So yeah, here's the final answer. So I'm glad I showed you the working out because when I did it again, I realized I made a mistake in the first time. So here's the final answer. P equals negative 3 root 2 over 4. So if you're wondering what does P stand for, what does P actually equals to a negative? Okay, is it negative? Why is it negative? Oh, because of a negative 6, right? Uh, multiply. When I differentiate. Yeah, that's right. Okay. And that's the end of lesson 12.5.